Good afternoon. My name is Rajiv Jain. I'm assistant professor in mathematics at Applied Science Department at Mid Malot. And today I'm going to deliver the lecture on the topic of differentiation using substitution with problems of the differentiation. First of all, I would like to revise some trigonometric relations which we'll be doing here. First is double angle formulas, like sine of 2a you have already done in previous lectures, like sine of 2a is equal to 2 sine a cos of a, cos of 2a is equal to cos square a minus sine square a, and from these basic identities like cos square a plus sine square a equal to 1, we can substitute the value of sine square a here and put the value here to get the expression like 2 cos square a minus a 1. Similarly, for this expression, if you put the value of cos square a here, and we get the value 1 minus 2 cosine square a here also. Then the value of tan 2a is equal to 2 tan a divided by 1 minus tan square a. Similarly, half angle formulas like sine square u is equal to 1 minus cos 2u by 2, cos square u is equal to 1 plus cos 2u by 2, tan square u is equal to 1 minus cos 2u divided by cos of 2u. These formulas are very useful in doing the substitutions as we do in the later stage of this lecture. And other formulas are sum to product formulas, and then we do for the product to sum formulas also, like sin u plus sin v is equal to 2 sin u plus v by 2 cos u minus v by 2. Similarly, sin u minus sin v is equal to 2 cos u plus v by 2 divided by into cosine of u minus v by 2. Similarly, if there are two cos functions cos u plus cos v, then formula becomes 2 cos u plus v by 2 cos u minus v by 2. Then if there are difference formula cos u minus cos v is equal to minus sine, here comes the minus sign here, minus 2 sine u plus v by 2 into sine u minus v by 2. These formula are very important. You have to learn it by writing it, or you have to do like if there are two signs, some are there, one sine function and other is cos function. If there is minus sign, then 2 cos u plus v by 2 sine u minus v by 2. If there are two cos functions, cos u plus v is equal to 2 cos u plus v by 2 cos u minus v by 2. Similarly, for minus, here come two sine functions. Then again, sum and difference formulas. Sum and difference formula you have already done. Cos u minus cos of x minus y is equal to cos x cos y plus sin x sin y. Cos x plus y is equal to cos x cos y minus sin x sin y. Sin x minus y is equal to sin x cos y minus cos x sin y. Similarly, sin x plus y is equal to sin x cos y plus cos x sin y. Tan x minus y is equal to tan x minus tan y, 1 plus tan x into tan y. Tan x plus y is equal to tan of x plus tan of y, 1 minus tan x tan y. Like if there is sin x plus y, the formula here becomes sin x cos y plus cos x sin y. When there is minus sign, it becomes minus here. But for the cos functions, when there is cos x plus y, cos x cos y, same functions are there, then for plus here comes the minus, and for minus here comes the plus. This thing we have to remember it. And similarly, for the cos tan functions, tan x minus y, here comes tan x minus tan y, and here comes the positive sign. When the tan x plus y is here, tan x plus tan y, and here comes the minus sign. And other formulas are product to sum formula. Like in previous slide we have done sum to product formulas. When two sine functions are there, you have sine u plus sine v, we have to write in the product form of these. Some formulas are there. Now when the product is given, like sine a into sine b, we have to show the different, that sine a sine b is equal to 1 by 2 cos of a minus b minus cos a plus b. and when both signs are there, then both signs product are there, product of two signs are there, then cos a minus b minus cos of a plus b. When product of two causes are there, then 1 by 2 cos a minus b plus cos a plus b. When there is product of one sine and a cos, ठीक है, then first if there is sine of a, then sine a plus b plus sine a minus b. When cos is cos, a is with the cos, then minus sign comes here, sine of a plus b minus sine a minus b. You may write it down, you get the formulas from your book also, so you can write it out, or you may learn it as soon as you possible. Then there is some other trigonometric formulas in which we have to show how we can write down the sine formulas in the terms of cos formulas, because these formulas are very useful when we doing the substitution, because we have to negate the inverse function to get the substitution. Like if there is sine of 2x, then 2 tan x divided by 1 plus tan square x, and when cos of 2x is equal to 1 minus tan square x divided by 1 plus tan square x. Tan 2x, 2 tan x, 1 minus tan square x. This thing we have already done. Similarly, some other more formulas there, like we have done the double angle formulas. Now there are triple angle formulas. These will also be useful in the substitution. When there is sine of 3x, this is 3 sin x minus 4 sin cube x, and when there is cos 3x, this is 4 cos cube x minus 3 cos x. Then tan 3x, this is equal to 3 tan x minus tan cube 1 minus 3 tan square x. Now these are very important formulas, and when we're doing that substitutions, we have to do the substitutions in the inverse functions, derivative of inverse functions, to negate the inverse functions. Now there is some inverse function trigonometric formulas. These may not you have done in the previous lectures or something like that. Now there is formula sine inverse plus minus. Plus minus mean first we read only plus here. Sine inverse x plus sine inverse y is equal to sine inverse x into root of 1 minus y square plus minus y root of 1 minus x square. This is very important formula. Similarly, for minus, sine inverse x minus sine inverse y is equal to sine inverse x root of 1 minus y square minus y into root of 1 minus x square. Similarly, for the cos also, this formula cos inverse x plus cos inverse y is equal to cos inverse x minus xy into, here comes minus xy minus root of 1 minus x square into 1 minus y square. And for the plus here, minus here, cos inverse x minus cos inverse y is equal to cos inverse x plus root of 1 minus x square into 1 minus y square. Now for the tan also, tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus x into y. And for the tan inverse x minus x tan y, here is y also. Tan inverse x minus tan inverse y, tan inverse x minus y 1 plus x into y. Like these are the inverse formulas. These are very much these tan formula are very much similar to the previous tan a plus b formulas, like we have done here in these. Tan x plus y, here comes the, if there is plus, here comes the plus, if there is, then in the bottom is it comes the minus. Similarly here also, this is tan inverse x plus tan inverse y is equal to tan inverse x plus y upon x minus xy. Now differentiation formulas. Previously we are doing the trigonometric formulas which we use in the questions. Now the differentiation formulas, like some basic formula you have already done, that is sine of x, derivative of sine of x is equal to cos of x, sine of cos of x is equal to minus sine of x, sine of tan x equal to secant square x, sine of cot square x is equal to minus cosecant square, like that. Now you are doing the inverse trigonometric formulas. Inverse trigonometric formulas are, first formula, that is for sine inverse x. This is d upon dx of sine inverse x is equal to 1 upon under root of 1 minus x square. This is very important formulas. You have to cram it, you have to write it, you have to learn it, everything you have to do the differentiation. Like d upon dx cosecant inverse x is equal to minus 1 upon root of 1 minus x square. D upon dx of tan inverse x is equal to 1 upon 1 plus x square. D upon dx of cotangent x minus 1 upon 1 plus x square. Like for secant square x is equal to 1 upon x root of x square minus 1. D upon dx of cosecant inverse x is equal to minus 1 upon x root of x square minus 1. You may write, like you have to learn the symmetry of these formula to learn it. Like in the derivative of sine inverse x, this is 1 upon root of 1 minus x square, and for the cosecant inverse x, this is minus of 1 upon root of 1 minus x. Only difference between sine inverse x and cos inverse x is there is only a minus sign here. Similarly, for the tangent inverse x, this is 1 plus 1 upon x square, and for the cotangent inverse x, here comes the minus sign. For the secant square inverse x, this is x upon x root of x square minus 1, and for the cosecant inverse x, here comes the minus sign. These formula, 6 formula which will be used in the inverse trigonometric derivative formulas. Now here come the part for our today's lecture, that is important substitutions to find the derivative of the inverse functions. Like first is, for here comes the expression having the terms and substitution which we will do here. First is, if there is the expression having the term a square minus x or under root of a square minus x, one of these, then the substitution will be of type x equal to a sin theta or x equal to a cos square x, cos theta. Because for the under root terms, if we put the value of a sin theta here, it becomes a square minus a square sin theta. That is, a square will common out, 1 minus cos sin square theta will become, and then this will become a cos theta. Then for the x square minus a square or under root of x square minus a square, that substitution will be a secant theta or x is equal to a cosecant theta, right. For the substitution of type a square plus x square or a square plus x square, the substitution formula will be x equal to a tan theta or x equal to a cot of theta. The basic later on, a plus x under root and a minus x under the root. If both the terms are involved, or single term is involved, then substitution formula will be x equal to a cos of 2 theta. If under root of a square plus x square and a square minus x square, then x square a square cos square 2 theta. If only one term a square minus x square is involved, then we put x equal to a cos sin theta or x equal to a cos theta. If only a square plus x square term is involved, then we put x equal to a tan theta or x equal to a cot theta. If both the terms are involved, then we put this x square equal to a square cos square 2 theta. The only thing with the substitution here is, if you put the substitution in the unroot form, the unroot will be cancelled out. Like if you put the value a cos theta or a sin theta here, a square minus a square sin square theta, this will become a cos theta. Similarly, if we put the value here, this will become a square secant square theta minus a square. A square will common out, secant square theta minus 1, secant square theta minus 1 will become tan square theta. So whole term will become a tan of theta. Similarly, here also, when you put the value of a tan theta here, a square plus a square tan square theta will become. Similarly, a square will be common out, 1 plus tan square theta, that will become secant square theta. So, and the whole term will become a secant theta. Similarly, here also, if you put the value of a cos 2 theta here, this will become a plus cos 2 theta. So, a cos theta, a will common out, 1 plus cos 2 theta, that will become 2 sin cos k theta. Similarly, for the minus term, this will become a into 1 minus cos theta, that will become 2 sin square theta. Now, here is the first problem we will be doing here. Find dy by dx if y is equal to sin inverse 2x root of 1 minus x square. Now we have to do the differentiation of this term with respect to x to find the value here. How to find it? We have y equal to sine inverse 2x root of 1 minus x. As I have told you earlier also, we have to do the substitution such that this term should be nullified to become the sine inverse and sine, and in the brackets the sign will should be become. So if here is a term involving, like here, as there is a term of type a square minus x square, a square minus x square term is there. So like in the first, for this a square minus x square, so either we can put a sin theta a or a cos theta. So we will put x equal to a sin theta, because the value of a here is 1, so we put x equal to sin theta. After putting the value here, this will become y sin inverse 2 sin theta root of 1 minus sin square theta. So and this term will become cos square theta, then taking the under root, this will become 2 sin theta cos theta. This 2 sin theta cos theta, as we have done told you earlier, this will become sine of 2 theta. So sine and sine inverse sine 2 theta, these sine and these sine will cancel out, so the term will become 2 theta 2 theta, and putting the value of theta again here, theta is because x equal to sine theta, so theta will become 2 sine inverse x. So y will become 2 sine inverse x. Now do the derivative. Y 2, because 2 is a constant, sine inverse x derivative is 1 upon root of 1 minus x square. So the dy by dx is equal to 2 upon root of 1 minus x square. The only thing we have to see here, the which type of terms is involved here from these the previous terms I have told you, that is either it is a square minus x square minus a square plus x square, a minus x and a plus x, or these two terms. If the one of these term is involved, we have to do the substitution in this manner, because in the previous question this is a square minus x square is involved, so we have put a x equal to a sin theta. Now another problem is there. Differentiate secant square 1 upon 2 x square minus 1. The value of x is lies between 1 upon root 2. It doesn't matter, because this is only for the definition of this secant square inverse x. Like see here, because in the bottom, because I have told you earlier, we have to cancel out these inverse functions. So inside the term should become secant. For this we have to put the value here x cos theta, so that it will become 1 upon 2 cos square theta minus 1. So 1 upon 2 cos square theta minus 1. So this will become 1 upon 2 cos 2 theta, and 1 upon 2 cos 2 theta, and it will become secant inverse secant 2 theta. Secant and secant will cancel out. The term will become 2 theta. We will put the value of theta from this equation here, that is cos inverse x. So y will becomes 2 cos inverse x. So we will do the derivative, dy by dx, 2 as it is, cos inverse x derivative is minus 1 upon root of 1 minus x square. Again, for to solve this type of question, we have to put the value of x such that the inside the bracket term should be become similar to the previous term, so that the inverse function should be cancelled out. Now another question is there, tan inverse root of 1 plus x square minus x. We have to do the derivative with respect to x here, because inside, now see this 1 plus x square plus a square. Now which type of term is involved? A square plus x square. Now you see a square plus x square, or a square plus x square under the root. So substitution will be either x equal to a tan theta or x equal to a cos theta. We will put x equal to a tan theta here, x equal to a tan theta. That is because a is a 1, so put x equal to tan theta. So y will become tan inverse y putting the value of tan theta in this expression, this will become 1 plus tan square theta minus tan theta. Now what is the value of 1 plus tan square theta? This is secant square theta. Secant square theta, root and secant square will cancel out. This will become secant theta minus tan theta. Now I have told you that these terms should be cancelled out, but this is not the way, so we have to simplify this expression also. So secant theta can be written as 1 upon cos theta, and tan theta can be written as sin theta upon cos theta. Now after simplification, LCM 1 minus sin theta upon cos theta. Now and we have to simplify this. 1 minus sin theta, this cannot be simplified because we have not any formula for 1 minus sin theta. So for this function, for that we have to change this sin theta into cos theta like this, because we know the cos of pi minus theta is equal to sin theta, and sin of pi minus theta is equal to cos theta. So previous expression, this will become 1 minus cos pi minus theta and 1 minus sin. Now what is the formula for 1 minus cos theta? That is 2 cos square theta by 2. 2 sin square theta by 2. 2 sin square theta by theta is whole function of theta whole by 2, that is pi by 4 minus theta by 2. And this sin function can be written as 2 sin theta by 2 cos theta by 2, that is sin pi by 4 minus theta by 2 cos pi by 4 minus theta by 2. This 2 and 2 will cancel out, this sin and sin will cancel out, the term only remaining will be sin pi by 4 minus theta by 2 divided by cos pi by 4 minus theta by 2. This is tan inverse tan pi by 4 minus theta by 2. This tan and tan will cancel out, so only term remaining will be pi by 4 minus theta by 2. So y will become, we put the value of theta here, that x, we have put x equal to tan theta, so theta will be equal to tan inverse x. So pi by 4 minus 1 by 2 tan inverse x. So do the derivative here. The derivative of pi by 4, because this is constant term, so it will be 0. 1 by 2 is as it is. Tan inverse derivative is 1 upon 1 plus x square. So this term will become minus 1 by 2 1 plus x square. The only thing is, we have to remember here, before the substitution, we have to see the term inside the brackets. What is the term inside the bracket? If the term inside the bracket is of type a square plus x square, we have the table. From that table we have to do the substitution, x equal to a tan of theta. Now other problem is this: sin inverse x of root of 1 minus x minus root of x, again there is bracket, root of 1 minus x square brackets, find dy by dx. Now this is different type of question. In the previous question we have put the value of x equal to 8 cos theta sin theta tan theta, but in this type of question, now see, we have to remember, we know sin inverse a minus sin inverse b is equal to sin inverse a root of 1 minus b square minus b root of 1 minus a square. We have to see the similarities between these two expressions. If we put the value of a here x and value of b is equal to root of x, value of a equal to x, then this expression will become right hand side sin inverse x root of 1 minus x root of x square will be x minus root of x root of 1 minus x square. So this expression can be written as sin inverse x minus sin inverse root of x. This is some different type of question. So now do the derivative here. What is the derivative of sin inverse x? This is 1 upon root of x square, sin inverse 1, this is 1 upon 1 minus x. Now derivative of this function root of x, that is by the chain rule, d upon dx is equal to x equal to 1 by 2. Derivative of x by x to the power n is 1 by n, 1 by n, that is 1 by 2 x n minus 1, that is minus 1 by 2. So after simplification, this will become 1 upon root of 1 minus x square minus 1 by 2 1 upon root of x under root of 1 minus xy. After simplifying it, this will become 1 under root of 1 minus x square minus 1 by 2 root of x minus x square. This is, we have to, in this question we have used this formula, which I will do. which I've earlier I have shown you to find the to break this inverse function into simple functions. Then there is another problem, tan inverse under root of 1 plus x minus root of 1 minus x divided by root of 1 plus x plus root of 1 minus x. We have to do the differentiation with respect to x. Now see, the terms are involving are a plus x as well as a minus x. So we will put x equal to a cos theta, x equal to cos theta. After putting x equal to cos theta, this term will become tan inverse root of 1 plus cos theta minus root of 1 minus theta under root of 1 plus cos theta plus under root of 1 minus theta. Now we know 1 plus cos theta is equal to 2 cos square theta by 2, and 1 minus cos theta is 2 sin square theta by 2, and again 1 plus cos theta is 2 cos square theta by 2 minus plus 2 sin square theta by 2. Now after simplifying it, we taken out the root 2 common here. The root 2 and root 2 from numerator and denominator will be cancelled out. So the term remaining will be cos theta by 2 minus sin theta by 2 divided by cos theta by 2 plus sin theta by 2. Now we have to simplify this. We will divide numerator and denominator both by cos theta. Dividing numerator and denominator by cos theta, this term will become 1 minus tan theta by 2, 1 plus tan theta by 2. The value of 1 will be, we have put the value of 1 here, that is tan pi by 4, tan pi by 4. Tan pi by 4 minus tan theta by 2, tan pi by 4 plus tan theta by 2. So simplifying it, this will become tan pi by 4 minus theta by 2. Tan and tan inverse will be cancelled out. Then the term remaining will be pi by 4 minus theta by 2. So y will become, we put the value of theta again here, that is cos inverse x. So y will become pi by 4 minus 1 by 2 cos inverse x. We do the derivative here. This derivative of pi by 4 will be 0, 1 minus 1 by 2 as it is. Cos inverse x is minus 1 upon root of 1 plus 1 minus x square. So this term will become the 1 by 2 and 1 by 2 will cancel out, 1 by 2 root of 1 minus x square. This formula we have used here is tan a minus tan b upon tan a plus tan b is equal to tan of a minus tan of b, right? Now there is another formula, another question. If under root of 1 minus x square plus root of 1 minus y square is equal to a x minus y, then prove that derivative is dy by dx is equal to 1 by y square under the root divided by root of 1 minus x square. In this type of questions, these are particular questions. We have to you have to cram it, which type of substitution we will do in this type of questions. We put x equal to sin theta here and y is equal to sine of phi here. You may also write x equal to cos theta and y equal to cos of phi. After putting these values, this expression will become root of 1 minus sin square theta plus 1 minus sin square phi under the root is equal to a sin theta minus sin phi. This will become cos square theta and this will become cos square phi. This will become a sin theta minus sin phi. Now again using the sum formula, 2 sin a plus sin cos b, 2 cos theta by 2 phi cos phi minus phi, and right hand side will become a 2 cos theta by 2 plus sin theta minus phi by 2. Now these two terms a and a cos will cancel out. Only term remaining will be cos theta minus phi by 2 is equal to a sin theta sin minus phi by 2. These term will be on the right hand side. So this will become tan theta minus phi by 2 is equal to 1 by a. Now a is equal to theta minus phi by 2 is equal to tan inverse 1 by a. Now substitution the value of theta and phi here. This will become sin inverse x minus sin inverse y is equal to 2 tan inverse 1 by a. So do the derivative on the both sides. Tan inverse x will become 1 upon root of 1 minus x square and tan inverse y will become 1 by root of 1 minus y square into dy by dx, because y is a function of x. And on the right hand side, there is only 2 tan inverse 1 by a, which is a constant term, so derivative will become 0. So after simplification, dy by dx will become root of 1 minus y square upon 1 minus x square, which we have to prove. Now another question is, dy by